Hi student, welcome to my YouTube channel. Today we start one new chapter in mathematics part 2nd, and name of the chapter is applications of definite integration. That is, in this chapter we find the area bounded by the curve with the help of the definite integration. So here we solve some problem on a definite integration, that is applications of definite integration. This is one major part in definite integration, because on this part one question for 4 marks in mathematics part 2nd will be asked in board examination. So this is one important unit. So first we write here one words problem, and we solve this words problem with the help of definite integration. So first we read here the problem. We already write here one problem. Find the area of sector bounded by the circle x square plus y square is equals to 16 and the line y is equals to x in the first quadrant. In this problem, we find the area bounded by the two curves. Equations of one of the curve is x square plus y square equals to 16, and we know that this equation is of the type that is x square plus y square equals to a square, is the standard equations of the circle with center at origin and radius is a. Similarly here this is the equations of the circle with center at origin and radius is 4. Next one equations, that is, and the line, one equations of the line is given, that is y is equals to x. We know that this is the linear equations of the straight line, and these equations, remember that these equations do not contain the constant term. Therefore the line represented by this equation passing through the origin, because here the given equation do not contain the constant term. Therefore the line represented by this equation, that is y is equals to x, passing through the origin. So first we draw here the figure, and then we shaded the sector which area is to be find out, because here we find the area of the sector in the first quadrant. So first we draw here the coordinate axis, and then we draw this circle, that is x square plus y square equals to 16. This is the equations of the circle with center at origin and radius is 4. So we draw here the circle. This is the given circle, of course standard circle, and equations of this circle is given, that is x square plus y square equals to 16. This is the equations of the circle with center at origin and radius is 4. Next we draw here the coordinate axis. We draw here coordinate axis, that is the x axis and y axis. So I know that this horizontal line is called as x axis, and vertical line is called as y axis, and point of intersections of these two lines is called as origin O, that is O00. Suppose here we assume that the given circle cuts the x-axis in point A, capital A, then OA is called as radius of the circle, and OA is given here because this is the equations, that is the standard equations of the circle with center at origin and radius is 4. So here OA is equals to 4. Then we write here the coordinate of this point A. point A lie on the x-axis, therefore y coordinate is 0. And next we find here the x coordinate, and x coordinate of the point A is a distance from the origin on the x-axis, and this distance is 4. Therefore here coordinate of point A, that is 4 comma 0. Here we find here the coordinate of the point A. Next we draw the line y is equals to x. Next we draw the line y is equals to x. This line, that is, this is the linear equations of the straight line. This equation do not contain the constant term. Therefore the line represented by this equation passing through the origin. So we draw here the line passing through the origin. So this is the line passing through the origin. And equations of this line is y is equals to x. And equations of this line is y is equals to x. Then here this line, that is the given line y is equals to x, intersect the given circle in point say B. In point say capital B. Then we find here the coordinate of the point B. We find here the coordinate of the point B. Remember that point B is a point of intersections of the given circle and the given line. So we solve these two equations and find out the values of x and y. X, that is the x coordinate of the point B. If I get the value of y, y is the y coordinate of the point B. Therefore here, first we write here the given equations of the circle and given equations of line. Since the given equations of circle, the given equation of circle is x square plus y square, which is equals to 16. Next we write here the given equations of the line. Since the given equation of line is y is equals to x. This is the given equations of the line y is equals to x. Then we solve these two equations for x and y. So we put y is equals to x in these equations. Y is equals to x in these equations. So we get here, therefore x square plus, we put here y is equals to x, so write x square equals to 16 as it is. Therefore here this x square plus x square, 2x square is equals to 16. Therefore x square is equals to 16 by 2. Therefore x square is equals to 16 by 2, that is 8. And then we find here the square root. Square root x is equals to here 2 root 2. Because here 8 can be written as 4 into 2. And square of 4, that is 2. Square root of 4, 2. And root 2, so square root of root 2 here. And this is the x coordinate of the point B, that is 2 root 2. Next we find here the y coordinate. Next we find here the y coordinate. Therefore y coordinate, which is equals to, here we put x is equals to 2 root 2, then we get the y coordinate. So we write here 2 root 2. Y coordinate of the point B is 2 root 2. So again we write here 2 root 2. Therefore here coordinate of point B, which is equivalent to 2 root 2, 2 root 2. And here our aim is to find out the area of the sector bounded by the given circle, line and x-axis in the first quadrant. So this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So we find here this area. This area is bounded by the given circle, given line and x-axis in the first quadrant. In the first quadrant, we find this area. This area. Next we draw here the line parallel to y-axis and passing through the point B. So we draw here the line parallel to y-axis and passing through the point, that point is point B. and we find this area. This area, that is the portion shaded by vertical line and portion shaded by horizontal line. We get the required area of the sector bounded by the line and the circle in the first quadrant. Next we draw the tangent to the circle passing through the point A. This is a tangent to the circle passing through the point A. Tangent to the circle. Here we write the equations of this line, and equations of this line passing through the point B parallel to y-axis is x coordinate of the point B. Therefore, equations of this line is x is equals to 2 root 2. Next we write equations of tangent passing through the point A and parallel to y-axis is x is equals to 4. X is equals to 4. Then required area bounded by the given circle and the given line and x-axis in the first quadrant is equals to this area plus this area. So first we write here the required area which is equals to required area is equals to integration within limit, that is equations of y-axis x is equals to 0. So we write here x is equals to 0 to x is equals to 2 root 2, x is equals to 2 root 2, y of upper curve and y of upper curve is x. So we write here x into dx plus, next we find this area. So integration, here lower limit is x is equals to 2 root 2. So write here x is equals to 2 root 2 root 2. Upper limit x is equals to 4. X is equals to 4 and y of circle. By now that the equations of the circle, equations of this circle is x square plus y square is equals to 16. From this we find y square is equals to 16 minus x square. Therefore y square, y is equals to under root 16 minus x square. Therefore y of this curve, which is equals to here under root 16 minus x square. This is the y of this sector of circle. So we write here under root 16 minus x square into dx. And then we evaluate the integrations. After evaluating the integrations, then put lower limit and upper limit, we get the required area bounded by the circle and the line and x-axis in the first quadrant. So we evaluate this definite integration. The required area, suppose this area is denoted by say capital A. Integrations, first we evaluate the integrations, that is indefinite integrations of x into dx. Use here the formula integrations of x to the power n into dx, x to the power n plus 1 upon n plus 1. Similarly here integrations of x into dx, x square by 2. So we write here x square by 2, x square by 2 within limit 0 to 2 root 2. Within limit 0 to 2 root 2. Next, we evaluate these integrations. And for evaluating these integrations, we use here the formula. By now that the formula in indefinite integration, that formula is integration under root a square minus x square into dx is equals to x by 2 under root a square minus x square plus a square by 2 sin inverse x by a plus c. We use this result. We already proved this result by using integration by parts method. So for this, by apply here formula plus here in bracket, use here formula under root a square minus x square. So this can be written as, by add here one step, x is equals to 2 root 2 to x is equals to 4 under root 16 can be written as 4 square minus x square into dx. 4 square minus x square into dx. Then apply here result, by write here result, apply this result, integration under root a square minus x square into dx is equals to x by 2 under root a square minus x square plus a square by 2 sin inverse x by a plus integrating constant c. Integration under root a square minus x square into dx is equals to x by 2 under root a square minus x square plus a square by 2 sin inverse x by a plus c. We use this result and evaluate these integrations. Therefore here required area A is equals to, first we put here upper limit minus lower limit. First we put x is equals to upper limit, that is 2 root 2. So we write here 2 root 2 whole square upon this 2 as it is, minus lower limit 0 square that is 0 by 2 0, plus in bracket, by evaluate these integrations by using this result. In this result simply by put a is equals to 4. जहाँ पे भी 4 है, जहाँ पे भी a है वहाँ पे आपको 4 लिखने का है. आपका आंसर राइट साइड के अंदर लिखने के बाद में आपका कंप्लीट हो जाएगा. So by write here x by 2 as it is under root a square, so write here 4 square minus x square, then plus a square by 2, 4 square by 2 sin inverse x by a, so x by 4 within limit, that is 2 root 2 to upper limit 4. In this result, in the RHS of this result, by put simply a is equals to this 4, then we get the answer of the indefinite integration. Therefore here required area A is equals to 2 square, that is 4, root 2 square, that is 2, 4 into 2 8 by 2. So write here 8 by 2 plus in bracket, first I put here upper limit. If I put here upper limit, then here also 4 square get cancelled, so 0 into this 0. That is, if we put the upper limit in the first term, we get here 0, because if I put here x is equals to 4, so we get 4 square, and this 4 square get cancelled, so we get 0 into this, so we get 0. Next we put here upper limit, that is here we write this 0 plus 4 square, that is 16 by 2, so write here 8. Sin inverse in bracket, by put here 4 by 4, that is 1, so write here 1. Sin inverse 1 minus, next we put here the lower limit, by put here lower limit 2 root 2 here, 2 root 2 upon 2, so write here root 2. Then I put here 2 root 2 and 2 root 2, that is 8, 16 minus 8, so we get here 8, that is root 2 into 8. Next here plus, again here 4 square 16 by 2, that is 8. Sin inverse, next we put here 2 root 2, So we write here 2 root 2 by 4. This bracket complete. Therefore here a is equals to 8 by 2, so write here 4, plus here 8, so write 8, sin inverse 1. But now that 1 is the value of pi by 2, so write here pi by 2, sin inverse 1, pi by 2, minus here root 2 into root 8, negative positive negative 8 sin inverse 2 1s are 1, 2 2s are 4, root 2 by 2, 2 can be written as root 2 whole square, so 1 by root 2, so write here 1 by root 2, 1 by root 2. Therefore a is equals to 4 plus 2 1s are 1, 2 4s are 8, so write here 4 pi, minus here this is root 2 into root 8, root 16, so write here 4, we write here 4, minus 8 sin inverse 1 by root 2, 1 by root 2 is the value of sin pi by 4, so sin inverse 1 by root 2 is pi by 4, so write here into pi by 4, into pi by 4, then here this 4 get cancelled, therefore a is equals to this 4 pi as it is, 4 1s are 1, 4 2s are 8, so write minus 2 pi, which is equals to 2 pi square units. This is the required area bounded by the given circle x square plus y square equals to 16 and the line y is equals to x in the first quadrant. In this way, we solve one problem on definite applications of definite integrations. Remember this unit is applications of definite integration. That is, with the help of the definite integrations, we find the area bounded by the curve. Okay, thanks.